Okay, it's a new topic, section 10.4. Okay, it's Pascal's triangle. Now, in the previous lecture, I told about combinations. Combination is a very important thing. So, n choose k means that I choose k objects out of n. K distinguishable objects. Let me just write distinguishable. K distinguishable objects. But important thing that order is not important. No order. Okay, in this case the number of combinations is n choose k. The number of ways to choose k positions out of n, or the number of ways to choose a set with k elements from the big set with n elements. Okay, and this is okay. I showed you how to calculate that. Fortunately, besides that symmetry, n choose k equals n choose n minus k, the number of ways to choose k elements is the same as the number of ways to choose the remaining n minus k elements. It's absolutely clear without formulas and without any calculation. Okay, so it's by definition, once you pick white marbles, at the same time you pick black marbles on the remaining parts. Okay, it was Pascal in France, and actually he was very young when he found out another connection between the combinations. Here, he wrote the following very strange triangular table. Okay, he started, if you want to write it down, start from the center, from the top of the center of your page. So write 1. Now, after that, write 1 on the left side and on the right side. And then you have to use the following rule. Write again 1 on the left side. After that, in the middle between those two ones, write the sum of those. So let me draw the arrows like that. And you write 2 here, which is the sum. And then extend 1 in here. Okay, now next, just here 1 goes in this way, 1 goes in that way, 2 goes in that way, and now 1 plus 2 will be 3. Now 2 goes in that way, 1 in that way, you have 3 again, and this one you have 1. You have the row 1, 3, 3, 1. Okay, keep going in this way. So we just write 1, then 4 between them, okay, then 6, then 4 between them, and this will be 1. Okay, let me just write more. 1, 5, 10, 10 again, 5 again, and then 1. And finally, okay, so I don't have enough room, but actually it's this triangle, okay, you see a triangle which goes to infinity. And so the 6th row is 1, 6, 15, 20, 15, okay, 6, and 1, and so on. And then you keep going. Now, look, the first row is actually the 0 row. 0 row. The first row starts with 2 1s. Okay, first row. Okay, second row is this one. Okay, third row is that one. And so this one is the 4th row, the 5th row, 6th row. So what is the number of the row? The number of the row is actually the numbers written in that diagonal after 1s. On the lateral, not on the lateral side, but a little bit shifted. Okay, you see 1, 2, 3, 4, 5, 6. So for example, fifth row, so 5 here. Sixth row is 6 here, and so on. Okay, look at these numbers. First of all, you see that they are symmetric. Okay, 3 and 3. So if you draw the vertical line through 1, 2, 6, and so on, this is the axis of symmetry. And you see that this 4 equals that 4. This 5 equals that 5. And then 10, 10, and so on. So in each row, you see the following. So if you consider the nth row, you will see the following. 1, then n, and then you will see, okay, so we'll just find that number, okay, and so on. And if you draw the graph of that, the graph will look like that. So in the beginning you have, if you put the column of width, just a stick of height corresponding to the number, you will have the following. So in the center you have the largest number, say 20 here, or maybe two largest numbers. If the row is odd, then you have two largest numbers. If it's even, then one largest number. Okay, anyway, the picture looks like that. It goes like this one, and then symmetrically will go to the right. Okay, so what is this, how that shape is called? The shape of this graph.
A bell?
Bell, yeah. Okay, it's called, okay, bell. Okay. Bell shape. Okay, so this is 1. Okay, that is 1. Okay, this is some number. This symmetric number is what's here. It turns out that these numbers, calculated in that very simple way, are exactly the combinations. So, for example, that 1 is actually n choose 0. When you choose nothing, there is only one way to do that. And the first one says so. 1 is the number of ways to choose nothing from n objects. So n choose 0. Now, if you take n elements and choose all of them, it will also one way. So n choose n is also equal to 1. This is 1, and that is 1. Okay, next numbers will be bigger and bigger and bigger. So suppose you have deal with the number, okay, you enumerate 1, 2, 3, 4, 5, 6, and this number k. And that number will be actually n minus k. Okay, that number will be n choose k. And then that is symmetry. And the other number is n choose n minus k. And now, so if you take, for example, some number r, n choose r, and symmetric will be n choose r. So you have equality here, equality there, and so on. So completely symmetric. If n equals n minus k, then k equals, if k equals n minus k, then 2k equals n, and so k equals n over 2. And exactly in the middle, so for example, the fourth row, what is that? It's in the middle it's 4 divided, so n divided by 2 will be 2, okay? You see, it depends on evenness. Sometimes it can't be divided by 2 if the row just, so it's 1, 2, 3. No, by the way, so the first digit, so the first number corresponds to 0, and then 1, and then 2. 4 divided by 2 will be 2. So on the second position, so that's on the 0 position. First position, second position. For example, here is 0 position, first position, which is 6 on the 6th row, then second position, third, 6 divided by 2 is 3. So third position, fourth, fifth, and the sixth position. So the first ones are not counted. From here, from this one up to the end, it will be exactly n positions. Okay, so therefore this number, in this case, n choose k, will be equal to n, no, sorry, not n choose k, in this case, what is that? Is n chooses n over 2. Okay, please don't write the bar between them. If you write the bar, it will be fraction, but if you don't write the bar, it's combinations. Okay, so we have the general picture, and that picture allows you also to say which number is bigger. For example, which number is bigger, a choose 3 or a choose 5? Okay, how to find that? You have to add 3 and 5. 3 and 5 is 8. Exactly the same as n. So therefore they are equal. Okay, so it's doesn't destroy. So suppose this one is 8 choose 3, then symmetrically will be 8 choose 5. Okay, now let's consider 8 choose 2 and 8 choose 7. Are they equal or not? You see, 8 choose 2 is located on the left side from the middle. It's in the eighth row, close to the left, and that one close to the right. Which one is closer? Which one is closer to the left and to the right? You see, 8. Next number after that will be 8 choose 8, and that number will be 8 choose 1 before that. Okay, 2 plus 7, you see, 2 plus 7 is 9. It's not 8. If it was 8, if it's here 6, then it would be equal. So you do the following. So you compare 8 choose 2 and 8 choose 7.
Good to go.
Okay, will we connect? So I interrupt it in the middle. Okay, so we compare which two numbers, which number is bigger than the other. It looks like that bigger because 7 bigger than 2. But let's look. 8 choose 2, we know it is the same as 8 choose 6. Where is located 8 choose 6? 8 choose 6 located on the left side of 8 choose 7. And they are equal. Okay? You know that the number on the right side is smaller. Okay, so therefore you find out that 8 choose 2 greater than 8 choose 7. Okay, this one is a little bit sophisticated, but first I want to rewrite this triangle, Pascal's triangle, in a little bit different way, just using that notation. So Pascal's, we just write instead of numbers, we'll just write notations for those. It's n choose 0. Okay, then n choose 1. Just 1 second. No, sorry, it's not that. What is that? So first one is 1 choose 0. No, even, you know, that number is actually 0 choose 0. Nothing, you have nothing, so the first one is a special, it's a vertex of the triangle, it's a special. So we start with that all the time. You can call it 0 choose 0. But next one is 1 choose 0 and 1 choose 1. Then you have 2 choose 0, 2 choose 1, and 2 choose 2. So increasing. This is 1, this is 2, and that is again 1. Okay, next you have, and so you have this one. 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Okay, will be 1, 3, 3, 1. No, yeah, 1, 3, 3, 1. Next you have 4 choose 0. And you see that 3 says the number of the row, so this is the third row. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And finally, what I had time is 4 choose, so now 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Okay, so you see that if you choose nothing, 0, then all the time this number is equal to 1. If you choose all of them, it will be also 1, symmetry. 5 choose 1 is all the time is 5. You choose one object out of 5. You have 5 objects, you can choose this, that, or that, 5 possibilities. But if you choose 4, it is the same as to choose 1, because if you choose 4, 1 remaining will be chosen automatically. So this number is equal to 5 as well, again symmetry. And 5 choose 2 is the number of ways to choose 2 elements. 5 choose 3 is the number of ways to choose 3. And they are equal, by the way, so look, 10 equals 10. So they are equal. This is 10, this is 10. But why they are equal without addressing to 10? 5 choose 2 is the number of ways to choose 2 objects. Okay, 1, 2, 3, 4, 5. Okay, so suppose I choose this one and that one. Then the other 3, okay, the other 3 automatically are chosen. So if I choose 2, I choose 3 at the same time. So the number of ways to choose 2 is the same as the number of ways to choose 3. I explained several times, but now you see the symmetry. Important thing is as follows. How did we find that triangle? How we found the numbers? So each number, say this 10, equals 6 plus 4. So the sum of those two. Let's look. For example, we have that small triangle inside. We have 2 numbers in a row in the fourth row, say. Okay, and then we go to the 5th row. And what do we see? We have to take that number, this number, add them up. Okay, one to the right, one to the left. Add them up and you get the answer. So we have the following. Let me write it down here. 4 choose 2 plus 4 choose 3 equals 5 choose 3. It's very interesting equality which comes immediately after this triangle. Let me just write general formula. N minus 1, n minus 1 choose. So n here, let n be 5 and k be 3. So n minus 1 is 5 minus 1 is 4. 3 minus 1 is 2. So we have that one plus again n minus 1, but this time you choose 3. So you choose k. They're located next to each other. And the answer will be the number from the other row, and this will be n choose k. And that is another fundamental formula for the combinations. Let me just explain this formula without without numbers, without calculation. So imagine that, for example, let me just write like this one. Say 19 choose 5 plus 19 choose 6 equals 20, choose 6. Okay. 20, choose 6. So suppose you have, there are 20 people. 20 people. I want to choose six of them. How many ways could I do this? 20, choose 6. You right? But I can do this calculated in a little bit sophisticated way. First, I consider some person out of 6. So suppose his name is Johnson. Okay, so one of them, and say, okay, Johnson, please, okay, go to shower for a second, and I will choose the other 5. So in this case, instead of 20 people, this Johnson just left. I have 19 people. And what I can choose only 5 people. So I've chosen so many ways I can choose these 5 people. Okay, then Johnson came. And what I have to do, now I have 6 people. So those 19 people do not include Johnson. But once Johnson came back, you have already 20 people again. But now I will consider only those 19 people in to which Johnson belong to. Okay, and so in this case I choose 6. That's why if I choose first 5 without Johnson and 6 with Johnson, out of 19, so 1 is out of it. It is the same as to choose 6 out of 20. That's why the equality calls. Okay, and that's why we can compare which number is bigger. So let me just explain once again how we found which number is bigger. So suppose I have 19, choose 5, and in the same row, 19, choose 15. Okay, which number is bigger? Now, first we add 15, 5 and 15. It's not 19. If it was 19, like here, 5 plus 3 is 8. And that's why these two numbers are symmetric. But 5 plus 15, unfortunately, is not 19, it's 20. Okay, which number gives me, okay, so we have the following. We have the bell, okay, we have the bell, and 19 choose 5 is that number. Now, which number is symmetric with respect to that one? Okay, the number, if this is 19 choose 5, the other one must be 19 choose 19 minus 5, which is 14. Where is it located? It's located on the left side of 19 choose 15, right? If it's on the left side, so therefore it's in here. Okay, somehow my picture is not very good, so suppose this one is. Okay, this is 19 choose 5, and that 19 choose 14. And because both of them are located on the right side, like that, on the right side, so this number is a stick of a little bit shorter stick. So therefore we know that this number is smaller than that, and those two are equal. You got it? Okay, so which number is bigger? 19 choose 5 or 19 choose 7? Okay, so if you divide by 2, so what is in the middle here? 19 divided by 2 will be, it's not divisible, right? But 19 divided by 2, it will be what? 9 and 8. So therefore, this 19 choose 8, and 19 choose 9. No, sorry. No, this one is 9 and this is 10. Okay, 9 plus 10 is 19, so they're equal. And they're in the middle. So 19 choose 5, 19 choose 7 are located on the left side from the symmetry. and therefore the smaller number on the bottom, the smaller the whole number of combinations. Okay, but that one is greater, for example, so it's equal 19 choose 12 if you subtract, and that one is bigger than, say, 19 choose 15. Why? Because from the center, 9 choose 12 is here, 12 position, and that one is 15, position 15. 15 is on the right side and also on the right side from the center. So that stick is longer than that stick. You got it, right? So now you can compare all the numbers of Pascal's triangle. Okay. I need to say, just from historical point of view, that Pascal's triangle was created initially in Italy, and only when Pascal created by himself, it was became well known, and that name came. Now this is the only name for that triangle. Okay, so let me just look. Okay, you see on the page 10, combination values in Pascal's triangle. So it's written the same way, but in the notation C choose C, N choose K. It's also up to the fifth row. So here is a problem on page 11. A group of 7 people includes 3 women and 4 men, and then 5 people are taken. Okay, let's write this problem. Okay, 7 people. So that is page number 11. 7 people. Okay, 3 women and how many? And 4 men. And then you choose 5. Choose 5. And how many different samples of 5 people are possible? So another important word used here is sample. Choose 5 people. Okay, so it's called samples. So what is the number of ways? What is the number of ways? So first of all, what do? You choose 5 people out of what? Out of 7. So therefore you take choose, okay, out of 7 you choose 5. 7 choose 5. You can calculate by formula, but also you can take the 7th row, okay, 7th row of Pascal's triangle. Let me draw Pascal's triangle like that. And 7th row gives immediately the answer. It's 7, by the way, 7 divided by 2 is 3, right? 7 choose 3 equals 7 choose 4, and 7 choose 5 is on the right side, so therefore it's smaller than 7 choose 4. And can be calculated, of course. And so this number is 21. If you look at this row, if you extend 2 more rows, you get 21. Now consider, so therefore there are 21 samples, 21 lists of 5 people, 25 samples, 21 different lists of paper or whatever, lists of 5 people. And now suppose, okay, so now you choose 5. 1, 2, 3, 4, 5. So 5 of them. Question is, how many of them would consist of 2 women plus 3 men? What is the number of ways? So for example, the women could be here, here, and this will be men. men, men. So first, what do? You have a sample of n equals 5, right? So now five positions. And you choose 2 positions first. Okay, so it's 5, choose 2. Oh no, sorry. No. Okay, where did you get this man, woman, man? From where? From this one, right? So first you choose women from women. So therefore, no, it's not true. So first you choose 2 women out of, out of 3 women. And 3 men you choose out of 4 men, right? So you have set of 3 women and set of 4 men. Then you choose 2 women. How many ways are there? It's 3, choose 2. You choose 2 out of 3. After that, so for the remaining part you choose, you have 4 men, but only 3 possibilities. So therefore you take out of 4 men, you choose 3. And then put them on the remaining positions. So this is the number of ways to choose 2 women out of 3. And this is 3 men out of 4. So therefore, by the fundamental principle, you have to multiply. And 3 choose 2. Okay, let's look. 3 choose 2. 3 choose 0, 3 choose 1, 3 choose 2. It's 3. So that number 3. Times, what is 4 choose 3? 4th row. 4 choose 0, choose 1, choose 2, choose 3. That's 4. Times 4. And the answer is 12 different possibilities. And this is the answer. Got it? This is how you can use triangle. Okay, next problem. You have 6 fair coins, and you toss all of them. In how many ways? Okay, so let me just write 6 coins. Okay, you toss them, and you get, after that you have 4 heads. Okay, 4 heads and surely 2 tails. Okay, heads, and this is tails. Okay, how many, so you just do this, and how many ways could it happen? So from 6 coins, okay, what is that? Okay, 3, 4, 5, 6. 4 of them are H. Suppose this one. So if you pick 4, and then the other one will be tails, right? Exactly. So you have to choose 6, choose 4. Okay, you have to choose the positions, and that's it. How to find that? Unfortunately, I didn't write. Oh, actually, I wrote this. The 6th row. What did I say? 6 choose 4, right? Okay, 6 choose 4, and this is, by the way, the same as 6 choose 2. If you choose 2 positions, which are this and that, it is the same thing. Once you choose 4 heads, the other 2 will be tails. And what is that? Just go to the 4th. 0, start with 0. 0, 1, 2, 3, 4, 15. And if you take the second one, it will be 0, 1, 2, also 15. That is written here. 15. If you want to use the formula says the following, this one. 6 factorial over 4 factorial, 2 factorial, and that one, of course, this one, 6 factorial over 2 factorial, 4 factorial, multiply here, multiply. Now what is that? It's 6 times 5, and up to the end, up to 4, so 4 factorial, 2 factorial is just 2, 4 factorial is same, cancel out, 6 and 2 cancel out, will be 3, and 3 times 5 is 15. The same number. Isn't it a miracle? Okay. Okay, the sixth row, what's written in here, the same is written on the page number 14 in the table. But actually it's better to write that one, and I highly recommend you, and maybe I give you a home assignment, I think about that, to write the Pascal's triangle up to the row number 20, in which case it will be pretty good practice. Okay, I want to finish that lecture about Pascal's triangle as follows. So I want to solve one problem in 4 different ways. Okay, let's write problem. Okay, let's write 20 people make all possible handshakes. Okay, question is, what is the number of handshakes? Okay, now I solve this problem in several different ways, starting with the way of the first part of our course, when we calculated, when we learned log plus minus 1. So let me write all the solutions here. And of course, all the solutions will give the same answer. So, first solution. First solution is the following. Okay, first person makes, how many handshakes does he make? Of course 19, right? Because he doesn't handshake himself, so it makes 19 shakes. Okay, second makes how many? 18 already, right? Second, because 1 makes handshake with number 2, with number 3 and so on. So number 2 already made handshake with number 1, and he makes handshakes with all the others, correct? So 18 shakes. Now number 3, third, will make 17. And so, and so on, right? So keep going. Now, finally, how many? 20. 19th person makes how many handshakes? 19th person.
One.
Are you sure that 1? Yeah. You see, regularity is as follows. 1, the number of a person plus the number of shakes is 20 all the time. 1 plus 19, 20, 2 plus 18. So if 19, then 1. And how about 20 person? 20. How many? 0. Actually, by this moment, 20 made all handshakes, and that's why he doesn't do this. So therefore, total number of handshakes is what? You have to add all the numbers. Okay, forget about 0. You have to add numbers 1, 2, 3, plus 4, and so on, up to 17, 18, and 19. How to do that? You know that it's Gauss did this when he was 10 years old, So what you have to do equals first number plus last number, 1 plus 19, times the number of numbers, which is 19, and divide by 2, because you split in pairs. 1 plus 19, 20, 2 plus 18, 20, and so on. So therefore, that's why you divide it by 2, find the number of pairs. So the answer is 20 times 19 over 2, 10, and the answer is 190. So therefore, the number of handshakes is 190. Okay. Second solution. You see, now we solve it a little bit different way. Okay, so almost the same, but it's a little bit different. So I put all the people along the circle, and then I consider one of them only. Suppose this guy, and he makes all possible handshakes. Okay, like that. How many handshakes will he get? 19. No, as before. As here. One person makes 19. So let's write number 19. Okay, he takes his notebook and write, okay, I made 19 handshakes. Okay. Second one, okay, how we calculated first time? So number 2 made already handshake in here, right? But we count in a little different way. So we consider this person as an independent person. And he makes, okay, all possible handshakes. And that handshake, the first handshake is already here. So he also writes in his notebook 19 handshakes. Doesn't he? Surely. So I made 19 handshakes, and every single one makes 19 handshakes. Okay, so if you connect, so including the previous one. Okay, 19, 19, 19. So everyone, there is no difference between the people. So what one writes in his notebook, then the other one does the same. 19, 19, so everywhere is 19. Okay, 19, 19, 19, 19. Okay, so everyone wrote 19. So therefore, the total number, okay, total number will be 19. Each one makes 19. How many people? 20. Multiplied by 20. And what do you see? Here we got 19 times 10. And this one we got 19 times 20. So twice as big as the previous one. Did we make a mistake? Or maybe the previous answer is incorrect? Okay, actually this answer is correct. And that one we must divide by 2. How come? Because this one person, this another person. When they make a handshake, one handshake, what does each write? I made one handshake. This write one handshake. Total 1 plus 1 is 2, but actually it's one handshake. One handshake in this direction, one handshake in that direction. It looks like 2, but actually it's 1. So 1 plus 1 is 2, and we have to divide by 2. So you see, each one has a double arrow handshake. So that's why in the end you have to divide by 2. Got it? And actually what you have the same formula as before, but the reasoning is different. Okay, times 10, so the same answer, 190. Okay, second solution. Okay, now I erase that one. Okay, this time I consider third solution. Where should it be better to write? Let me just write on the left side. Okay, this time I calculated in a little bit different way. Okay, I will do this as follows. Third solution. I drew a table and write the numbers 1, 2, 3, 4, 5, 6, okay, 18, 19, and 20. And do the same here. I just write the table 1, 2, 3, 4, 5, 6, 7, 19, and 20. And what do I do? So first of all, okay, so I have a table. I don't want to draw it. First of all, I know that 2, okay, 1 and 1. So each person doesn't shake his hand himself, right? So, okay, those diagonals should be removed. Okay. So therefore, this one is not counted. Now, if suppose I take 3 and 6, suppose 3 and 6. Okay, I take this square, and if I make handshake, I just make a mark here. But you see, 3 makes handshake with 6, and therefore number 6 at the same time makes handshake with 3. So therefore I mark immediately two squares, right? 2 squares. Okay, so the number of handshakes actually, that's why we divided by 2 here. And the number of handshakes could be calculated as follows. If you have to take all the squares here, remove the diagonal, and after that you have 2 disjoint sets with the same number of rows, number of squares. So I have to subtract this one and divide by 2. Okay, let's do this. So 20 times 20 minus diagonal, which is also 20, and then divide by 2. Okay, for those who knows a little bit algebra, this is the same as if you take 20 out of the parentheses. It will be 20 times 20 minus 1, which is times 1. So if I take 20 out of the parentheses, it will be 20 minus 1, and divide by 2, which is 20 times 19 divided by 2, or 400 minus 20. Maybe this is easier. Okay, so let me just compare. So it will be the same 10 times 19, the same answer 119, but calculated in a little bit different way. If I don't divide by, if I don't take out of the parentheses, then I could do this as follows. It's just divide by 2 will be 10 times 20 and minus 10. So it will be 200 minus 10, and the answer is 190. The same thing. Okay, this is the third solution. And finally, we go to the combinatorial solution, to our topic. Fourth solution. Okay. So what is the handshake? We have, so 2 people. We have to choose 2 people, right? 20, and we have to choose 2. This is the answer. Okay, so this is the answer. That's right. You see, instead of making this reasoning, and that one, so you just choose 2 people. And now let's calculate. Maybe we are wrong. So what is that? It's 220 factorial over 2 factorial times 18 factorial equals 20 times 19 times what? 18 factorial, right? Here we have also 18 factorial, and this you have 2 factorial, which is 2 times 1. Cancelled out, and what do we have? You have 20 times 19 divided by 2. Look, all the formulas are the same. 20 times 19 divided by 2. 20 times 19 divided by 2. And that formula with factorials, okay, cancelled out, and you find the answer is the same answer, 109. So in 4 different ways, we solve the same problem and find the same answer, but logic is absolutely different, and the shortest one is that one, of course. Choose 2 positions, 2 people out of 20. This will be so many pairs, so many handshakes, 190. Okay, so that's it with this topic, and we'll go to the next one. Thank you.